Hello, there's been some interest in scope traces. This yellow signal, this is the drain of the FET, and what I've done is I've inverted the signal. So this is actually at 0 volts and this is at the full voltage of the power supply. And so this actually indicates when the FET is on, it actually drops to 0 volts. And so I think that's more intuitive to watch. So this time here is when the FET has turned on, and you'll see that the on gets longer, the off gets shorter, back and forth. Now this is pin 3 of the IR2153. At the very bottom edge down here, this is 0 volts. This is about 1.3 volts. The diodes provide that voltage, those two diodes in series with pin 3, and that allows the reset to happen much quicker. And so when it's down here, basically you've turned it off, as you can see from this waveform there, and it has to get up to 5 volts in order for it to turn on. This takes a little over a millisecond to get to that point, and once it's on, it'll stay on until the voltage drops. And you can see from this top edge here, this is our limiter, and that prevents the IR2153 timing capacitor from getting up to 10 volts, at which time it would there's an internal flip-flop that would turn on the second channel. But if you watch this, there's there's changes as you get some little clouds. Sometimes it's hard to see, but everything's moving all the time. And this on period, as I've getting up to full power, this is probably around 6 milliseconds that it's on. And I've seen it where the on period goes up. I've seen it at 48 milliseconds before it shuts off. And if the sun is bright enough, it just turns on and stays on. So that's very efficient. But let me turn this off a second. Now we're actually looking on this green trace of the AC waveform on the capacitors. The capacitors are about 60 volts. But if you look right down here, you'll see the difference between this line and that line is 2.1 volts. And that's how much the capacitors drop between when it turns on and when it turns off. As you can see, when it's on, the voltage drops, and when it's off, the voltage starts climbing again. So yeah, we're around 2.1 volts, and you want to keep this voltage as close to constant as possible. And 2 volts on 60, you're about 2 or 3%, so that's pretty good. But that's what I wanted to show you, and right now we're at about 190 watts on this 500 watt array. All the interesting stuff happens at lower power, so that's why I show it. So thanks for watching. Any questions, please ask.